Okay, guys, we're doing related rates, and I'm probably going to separate these out because not everybody has problems with the same type of problem, right? Um, because they can be long or tedious, right? But we're going to go do activity number 3 first. And the first thing it says, you want to differentiate this with respect to time, all right? So I'm going to differentiate this with respect to time. They tell me that dy dt, they want me to find this when x equals 1 and dx dt equals 2. So first, we need to find y. So y squared, let's go ahead and find this y. And you're asking me why, because that's going to matter when we implicitly differentiate right here. So y squared equals 3 times 1 to the fourth plus 6 times 1. This equals y squared equals 3 plus 6 or 9. So y squared. I want to get y on its own, so I'm going to take the square root of both sides, and y is equal to 3. Now this is going to help me tremendously because I have x equals 1, I have dx dt equals 2. So let's implicitly differentiate here. So I have 2y dy. Remember, this is with respect to t. I have 12x squared, third to the third, 12x to the third, dx dt, because we were doing this with respect to time, and you know that because they asked me explicitly to find this in terms of that. We're used to not doing that, but now that's where we're at. So 6 and dx dt. Things that I know. I know what y is. I know what x is. And I know what dx dt is. Things that I don't know is that dy dt right there. So that's okay because we can solve for it just using simple algebra. So 2 times 3 dy dt equals 12 times 1 cubed times 2 plus 6 times 2. Okay, so I have 6 dy dt equals 24 plus 12. Okay, dy dt equals 6, 36 over 6, and my answer is 6. dy dt is 6. So it says the width of a rectangle is increasing at a rate of 2 centimeters per second. So dw, this this is the rate, is dw dt. So I have 2 centimeters, I have centimeters over second. That's how I know. And then it's increasing, so it's positive. The length, dl dt, is increasing at 3 centimeters per second. At what rate is the area of the rectangle increasing? When its width is 4 and its length is 5. So here is my area formula. It's L times W. And remember, we want to use the product rule here. So f prime of x is dl dt. G of x is W. G prime of x is dw dt. And with respect to time, this becomes w dl dt plus l dw dt. This equals 4 times 3, and that's going to be centimeters squared per second. That's the units, plus up here we have L, which is 5 centimeters, times 2 centimeters per second, and I get 10 centimeters squared over seconds. And the final answer here, this area is increasing at 20 centimeters squared per second. Okay, next it says a police car approaching a right-angled intersection to the north is chasing a speeding car that has turned the corner and is now moving straight east. When the police car is 0.6 miles north, so it's 0.6 miles north, so y equals 0.6, this will be my y value here, and the car is 8.8 miles east, the police determine with a radar gun that the distance between them and the car is increasing at 20 miles per hour. So this distance over here, we'll call it R, whatever you want to call it, I don't care. So dr dt is 20 miles per hour. That means we call this R. If the police car is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? So basically, what is dx dt? I get dy dt. This is the police car, and it's 60 miles per hour. All right. So what equation can I use to relate this? So this looks like Pythagorean theorem here, and R is just going to be, I can get R pretty easily. So think about the Pythagorean theorem. It's that the sides, both those sides squared, the sum of both sides squared equals the hypotenuse squared, right? So let's replace this with the variables that I used. You can use these variables, but it just depends on what you want to do. So I have 0.6 squared plus 0.8 squared equals r squared, right? So that's 0.36 plus 0.64 equals 1. So r equals 1. All right, so I have r. So let's go ahead and do some implicit differentiation, and not just any kind, but implicit differentiation with respect to time. If you don't remember, these are functions. These are functions of time. These are functions of time. Okay? So with respect to time, I have 2x dx dt plus 2y dy dt equals 2r dr dt. And if you notice, I have a lot of things already. This is where the highlighter comes in handy. I have dy dt, it's right there. I have y, it's right here. I have dr dt. I have r. I have x. Don't have dx dt. So I'm just going to plug those in, use some algebra, and solve. So 2 times 0.8. I have dx dt, which I'm solving for, plus 2 times 0.6 times 60 equals 2 times 1 times 20. I get 1.6 dx dt plus 1.2 times 60 is 72 equals 2 times 20 is 40. Subtract that on both sides, and it looks like the speed is decreasing. So dx dt equals 72 minus 40 over 1.6. That's going to give me 2, 42, or 32. 32 over 1.6, and I'm going to get equals 20 miles per hour. And guess what? It's negative 20 miles per hour. Preferably, you would write negative 20 miles per hour. Okay, and that's all of your activity. Going to move on to related rates and have a blast.